Welcome. Today we'll solve the differential equation x, y prime equals y plus x squared sine x with the initial condition y of pi equals 0. Let's solve this step by step. First, let's rearrange the equation to standard form. We'll move all terms with y to one side and all other terms to the other side. This is a linear first-order differential equation. We can write it in standard form by dividing everything by x. This gives us y prime minus y over x equals x sine x. To solve this, we'll use the integrating factor method. The integrating factor is e to the negative integral of p of x dx, where p of x is the coefficient of y, which in this case is negative 1 over x. Let's solve for the integrating factor. Negative integral of negative 1 over x dx equals integral of 1 over x dx, which equals natural log of absolute value of x. Therefore, our integrating factor is e to the ln of absolute x, which simplifies to just absolute value of x. Now multiply both sides of the equation by the integrating factor. This gives us absolute x times y prime minus y equals absolute x times x sine x. The left side is now the derivative of absolute x times y. So we can write this as d over dx of absolute x y equals absolute x times x sine x. Now we can integrate both sides. The integral of absolute x times x sine x dx can be found using integration by parts. After integrating and solving for y, we get y equals x sine x minus cosine x plus c over absolute x. Finally, we can use the initial condition y of pi equals 0 to find c. Plugging in x equals pi, we get 0 equals pi sine pi minus cosine pi plus c over absolute pi. Since sine pi is 0 and cosine pi is negative 1, we get c equals pi. Therefore, the particular solution that satisfies our initial condition is y equals x sine x minus cosine x plus pi over absolute x.